Dear students, welcome to Chemistry Classroom. In today's lecture, we are going to look at mole mass conversion in stoichiometry. This is the equation that we will use for our calculation. The first conversion that we will look at is mole to mole conversion. The second conversion that we will look at is mole to mass conversion. And finally, we will look at mass to mass conversion. Let's look at each of these calculations one by one. So this is going to be the equation that we will use to convert a substance from one unit to another unit. So the first one is mole to mole conversion. As you know, the amount of hydrogen given is 100 mole and we have to calculate the amount of ammonia produced in moles. So how we would do that? First, we will look at the balanced chemical equation. Now over here you can see when 3 moles of hydrogen are burned, we get 2 moles of ammonia. Now if we have 100 moles of hydrogen, what will be the amount of ammonia produced in moles? Now you can see from the balanced chemical equation, if 3 moles of hydrogen are reacted with nitrogen, we get 2 moles of ammonia. And we can read this equation like this. 3 moles of hydrogen gives 2 mole of ammonia. Just read this equal sign as give. Now using this simple relationship, we can calculate how much is the amount of ammonia produced by burning 1 mole of hydrogen. If we get it for 1 mole, then it is easy to calculate for 100 moles. So we can write like this. You can see now you can actually divide this 2 by 3 and this would give us 1 mole of hydrogen, which is equal to 2 by 3 moles of ammonia. Now when you know 1 mole of hydrogen gives this much amount of ammonia, then we can easily calculate for 100 moles of hydrogen. We simply need to multiply 2 by 3 with 100, and there you can see 100 moles of hydrogen would give us 2 by 3 into 100 moles of ammonia, and this would give us 66.66 moles of ammonia. I hope this was easy to follow, but if you find it a little bit confusing, then let me show you the other method. That is simply a ratio method. Simply write hydrogen on one side of the ratio and ammonia on the other side. Now you can see from the balanced chemical equation, if we have 3 moles of hydrogen, we would get 2 moles of ammonia. And now we are given 100 moles of hydrogen, then the amount of ammonia produced we don't know, so we are going to put X in its place. Now simply cross multiply. Now the two quantities that are known are 100 into 2. So we simply multiply 100 with 2 and we will divide it by 3 and we would get X like this. 100 multiplied with 2 divided by 3 and this would give us X, and you know X belongs to ammonia. So the answer again is 66.66 moles of ammonia. So this was mole to mole conversion. Now let's look at the other conversion, that is mole to mass conversion. Again, the amount of hydrogen that we are given is 100 mole and we have to calculate ammonia produced in grams. Now the hydrogen is given in moles and we have to calculate the amount of ammonia produced in grams. So how we would do that? Again, this is pretty much similar to the calculation that we have done earlier. 3 moles of hydrogen gives us 2 moles of ammonia, and 1 mole of hydrogen would give us 2 by 3 moles of ammonia, and 100 mole would give us 2 by 3 into 100 moles of ammonia, and finally we would get 66.6 moles of ammonia. But you know, we have to calculate ammonia in grams, not in moles. Finally we will convert these 66.66 moles into grams. And how we can do that? Simply multiply it with molar mass of ammonia. The molar mass of ammonia is 17 gram per mole. We are going to multiply it with 66.66 moles and we would get 1133.22 gram ammonia. Again, if you find it a little bit confusing, then you can use the alternative method, that is the ratio method. Hydrogen, other side you would have ammonia. 3 moles of hydrogen gives us 2 moles of ammonia and 100 mole would give us X moles of ammonia. Simply cross multiply. The two quantities known would be multiplied, divided by the other known quantity, and it would give us X, that is the amount of ammonia produced, and you can follow the rest as we have done now. Now finally we will look at mass to mass conversion. So you can see amount of hydrogen this time is 100 gram, and now we have to calculate amount of ammonia produced in grams by reacting 100 gram of hydrogen with nitrogen. So first we need to convert grams into moles because the balanced chemical equation talks only in terms of moles, not in grams. So we can actually convert these 100 grams into mole first. For that, this is the simple relationship that we normally use: weight in grams divided by atomic weight or molecular weight. This would give us the number of moles. So here we have 100 gram of hydrogen, and the molar mass of hydrogen is simply 1 gram per mole, and this would give us 100 moles of hydrogen. So the first step is done. We have converted 100 grams into moles, and this was too simple. We have got 100 moles of hydrogen, and rest is the same. We will follow the balanced chemical equation. 3 moles of hydrogen would give us 2 moles of ammonia, and 1 mole of hydrogen would give us 2 by 3 moles of ammonia, and we would multiply 100 moles of hydrogen with 2 by 3, and this would give us 66.66 moles of ammonia. Now we have calculated the amount of ammonia produced in moles. Now we need to convert it into grams. So again, it's pretty simple. In grams, 66.66 multiplied with 17 gram, and this is going to be the amount that would be produced by burning 100 gram of hydrogen. And alternative method is too simple, and there is the amount of ammonia produced in grams. So this was all about mole mass conversion in chemistry. I hope you have found this tutorial useful. Please give this video a thumbs up, subscribe to my channel, and thanks for watching.